Okay, now today let's start today's assignment solving session. So today I'm gonna solve the assignment which had been given previous year. So let's start. So we'll start. Okay, question number one. Question number one. We'll start from question number one. So Krishna, my screen and voice is visible too? Okay. Let's start. So question number one is there are n random variable x1, x2. They are identically independent random variable with exponentially distributed random variable. Exponentially distributed random variable with mean parameter 1 by beta. Now we have to find the expectation value of the order statistics of order 1. Okay, so we have to find the probability distribution of the x1 first. So to calculate its probability distribution, we first see the CDF of x1. So the CDF of x1 is given by that CDF means probability of x1 should be less than equal to x, and this is equivalent to say 1 minus probability of x1 greater than x. This means 1 minus the in order statistics we know all the other n minus 1 variable, that is x2, x3, they all are greater than x1. So if x1 already greater than x, that actually implies x2, x3 and x also in all n minus 1th random order variable should also be greater than x. So that means this is equivalent to x1 greater than x, x2 greater than x, x n greater than x. And since these variables are identically independent random variables, so that means this joint probability distribution can be written in as a product x1 greater than x, x2 greater than x, x n greater than x. And since these every random variables are follows exponential distribution, so that means these will be these px, sorry, this is okay, this is equivalent to say x1. Suppose the random variable x1, this is x1, x2, x2, xn. So that means these, we know that for exponential distribution the p x greater than x is nothing but e to the power x by its mean. So it will minus x by its mean is beta 1 by beta, so the beta will be like that, so 1 minus beta x. So similarly x2 also a random variable with same distribution, that means this, so up to n. So this distribution will look like 1 minus e to the power n beta x. So therefore the distribution of x1 is distribution of x1 at x is derivative of x respect to this probability of x1 greater than equal to small x. So this is nothing but derivative of this, so this is n beta e to the power minus beta x. Now we have the distribution. Now we have to find the expectation value. What is the expectation? Expectation is 0 to infinity x f x1 x dx. So that is 0 to infinity n beta x e to the power minus, there will be a n minus n beta x dx. Suppose y equal to, let y equal to minus n beta x, then dy will be n beta dx, means dx will be dy by n beta, so that is 0 to infinity, this is y e to the power minus y, and dx means dy by n beta, so this is 1 by n beta. And let's integrate by parts. So first y integration of e to the power minus y is e to the power minus y minus derivative of first term, so that is still same, and e to the power minus y integration of e to the power minus y, again e to the power minus y dy. I have to integrate 0 to infinity 1 by n beta. This is at 0, this is 0, at infinity this is 0, so these will not contribute. So again we'll see the integration of e to the power minus y, so it minus of minus e to the power y 0 to infinity, so this is 1 by n beta minus 0 plus 1, so that is 1 by n beta. So the expectation value of this order statistics of order first order is nothing but 1 by n beta. So that is the answer of the first question. Now let's move toward the second question. Question 2. Yeah. Question 2. Let's move toward the question 2. Question 2 is x1 x2 x10. So question 2 is that is x1 x2 xn are identically independent random variable, each follows the normal distribution. This follows normal 0 to 1 distribution. Now we have to find the expectation value of summation of I equal to 1 to n xi square and the variance of I equal to 1 to n, variance and expectation of xi square. And as we know, the square of any normal distribution, any normal standard normal distribution is a chi-square distribution with order parameter 1. And we also know that if we sum over n order n, suppose this is n in random variable, independent identical random variable who follows the chi-square distribution, then the summation will be also follows the chi-square distribution with, suppose this is order of ni I equal to 1 to suppose k, then this random variable, new summation random variable will follow a chi-square distribution with order parameter summation of ni I equal to 1 to k. So that means if there are n independent random variables are there, and if xi square follows a chi-square distribution, chi-square 1, so the n summation of this all n will follow that means suppose a random variable, suppose y denote random variable summation I equal to 1 to n x square. So that means this will follow a chi-square distribution with order parameter n. Yeah, okay, order parameter n. Yeah, then let's see the expectation of xi square. So now we have to find the expectation of y. So that is, let me see the distribution. Okay, yeah, so that means we have to find the expectation of y chi-square n dy. This is 0 to infinity. So let's say it. So this is 0 to infinity y. This chi-square n is 1 by 2 to the power n by 2 comma n by 2 e to the power minus y by 2 y to the power n by 2 minus 1 dy. So this is 0 to infinity 1 by 2 to the power n by 2 gamma n by 2 to the power minus y by 2 y to the power n by 2 dy. Now let's we have to make it another gamma variable. So take n by 2 is equal to k minus 1, or rather put it in this way. So let's multiply upper and lower side both by n by 2 comma n by 2 e to the power minus y by 2 y to the power n by 2 dy. So that means n 0 to infinity 1 by 2 to the power n by 2 plus 1, this is comma n by 2 plus 1, this is e to the power minus y by 2 y to the power n by 2 plus 1 minus 1 dy. So this is nothing but again a gamma distribution, and since the normalization condition follows, so this will be 1. So this is n. That means expectation of this square summation is n. And let's see what is the variance. To check its variance, we have to first calculate its expectation of y square. That will be 0 to infinity y square 1 by 2 to the power n by 2 gamma n by 2 to the power minus y by 2 y to the power n by 2 minus 1 dy. So then these will become 1 by 2 to the power n by 2 gamma n by 2 e to the power minus y by 2 y n by 2 plus 1. Now we have to multiply both side by n by 2 plus 1 and n by 2, that will be 2 to the power n by 2 n by 2 plus 1 n by 2 comma n by 2, this will be to the power minus y by 2 y to the power n by 2 plus 1 dy. So from up we will get n plus 2 by n, this is again 1 by 2 to the power n by 2 plus 2, this is nothing but gamma n by 2 plus 2, this is e to the power minus y by 2 y to the power n by 2 plus 2 minus 1 dy. So this is again 1, so this is n into n plus 2. Then variance of y will be expectation of y square minus expectation of y its square, so that is n plus 2 into n minus n square, which will be n square plus 2n minus n square, that is nothing but 2n. That's it. Now this is the question number 2. Now let's move toward the question number 3. Question number 3. Okay, question number 3. Yeah. Question number 3 is following. Carbon monoxide, let me write it, a carbon monoxide emission for a certain kind of car varying with mean 2.9 gram per mileage and standard deviation is 0.4 gram per mile. A company has 80 cars in its fleet acquired from various, that is random sources. Assume that carbon monoxide emissions of cars are independent and normally distributed find the probability that randomly selected car from the fleet has CO emission in excess of 3.1 gram per mile. So let's see. So we have to calculate. Here the random variable AX follows a normal distribution with mean 2.9 and standard deviation 0.4. We have to find the probability of X greater than 3.1. So this is basically probability. If we convert it to the standard normal distribution, so that will be X minus 2.9 by 0.4 square should be greater than 3.1 minus 2.9 by 0.4 square. So this is probability of this is Z greater than this is 3.1 minus 2.9. So this is 0.4, not 0.4 square, 0.4. So 0.2 by 0.4. So that is probability of Z greater than 0.5. So that probability is from the table. We got the probability is 0.3085. That's it. That's the answer. Now let's move toward the next question, that is question number 4. Okay, here it is given that X and Y both follows a normal distribution with mean mu and standard deviation 1, and there is these two are not independent variable. There is a covariance between them, and correlation coefficient is 0.5. Now we have to find the probability of X plus 2y less than 3, and we have to find the this mean such that probability of X plus 2y less than equal to 3 is the probability 2x minus y greater than equal to 4. How to find that? So let's see. We know that any linear combination of normally distributed random variable is again a normal distribution. So if then that means 2x plus y also should be a normal distribution with some mean and some standard deviation, and this 2x minus y also a normal distribution with some mean and some standard deviation. So let's calculate what is its mean. So mu1 will be the expectation of X plus 2y. So this means expectation of X plus expectation of y. So this is mu plus 2 mu, so this is 3 mu. Now let's see variance of X plus 2y, and from the formula we know that variance of X plus 2y is variance of X plus 4 into variance of y plus 4 into variance of covariance of x y, covariance of x y, and correlation coefficient means covariance by sigma x into sigma y. So that is that covariance xy will be rho xy into sigma x sigma y. So that is, since sigma y is same 1, so this is rho xy, so nothing but rho xy. Rho and rho xy is 0.5. Let's see variance of 1, this is 4 into 1, this is 4 into 0.5, so this is 7. Now similarly, the let's see expectation of second variable, that is 2x minus y. So that will be 2 expectation of x minus expectation of y, so that is 2 mu minus mu, that is mu, and variance of 2x minus y is 4 variance of x plus variance of y minus 4 variance covariance of xy. So this is 4 plus 1 minus 4 into 0.5, so that is 5 minus 2, so that is 3. Then we know the distribution of, that means distribution of x plus 2y is normal distribution with mean 3 mu, and the variance is 7, and the random variable 2x minus y, these also normally distributed with normal with mean mu and variance 3. Now we have it is said in the problem, the probability that x plus 2y less than 3 is equal to probability of 2x minus y greater than equal to 4. So let's change this variable to a standard normal variable. That means probability of x plus 2y minus mu pi root 3 root 7, I think root 7 less than equal to 3 minus mu by root 7 equal to probability of 2x minus y mu. So this is actually, I think, 3 mu. This is 3 mu minus mu by root 3 greater than equal to 4 minus mu by root 3. So this is equivalent to probability that z less than 3 minus 3 mu by root 7, and probability that again z greater than 4 minus mu by root 3, and this means by root 7, this is equivalent, we can say that this actually mean this is equal to says this is minus z less than equal to 4 minus mu by root 3. Since it's a symmetric distribution, so symmetric about z, z equal to 0, so this means 3 minus 3 mu root 7, so this is actually same as probability of z less than equal to 4 minus mu by root 3. And from the two side we can say that 3 minus 3 mu by root 7 is equal to 4 minus mu by root 3. So if I do it, that means let's calculate it, 3 minus mu into root 3 equal to 4 minus mu root 7. So okay, 3 root 3 minus 4 root 7 equal to 3 root 3 plus 4 root 7 into mu. Okay, that means mu is 3 root 3 minus 4 root 7 by 3 root 3 Okay, let's see. I think I made some mistakes somewhere. Here it's 3. Okay, there in the mu, this is, I think, this root 7 minus mu. So this is 3. Oh, I do a this is not, this is mu minus 4, so minus z less than mu minus 4, so this is mu minus 4, mu minus 4 by root 3, so this is mu minus 4, so this will be plus, and this again with plus, so root 3 plus root 7. So this is the answer. So now let's move toward the question number 5. So question number 5. Okay. Question number 5 is x and y are IID random variables with everyone has the probability distribution half e to the power minus x by 2, where x greater than equal to 0. Then which of the following is not correct? A, half x minus y have Laplace distribution. B, expectation of half x minus y equal to 0. C, half x minus y have normally distributed. And D, half x minus y is symmetric. So let's see. Now let's redefine two new first see what is the since it is IID, so that means joint distribution will be simply the multiplication, so that will be 1 by 4 e to the power minus x plus y by 2 for x greater than equal to 0, y greater than equal to 0. Now let's redefine two variables. One is u, another random variable is suppose x plus y, and v half x minus y. Now thus x will be, real variable x will be u plus p, u plus p, and y will be u minus p. The minimum value x can take is 0. That means x minimum value x can take is 0, and minimum value y can take is 0. So that means these u v variables, and actually I want to find the range of this u v variable. So one is u minus v, one is u plus p equal to 0. So they should be these u and v. Okay, let me do it. So Okay, so this minimum value is 0. That means EV, okay, you can minimum value you can take, okay, so the minimum value you can take is minus V, and these and Y also is 0. That means the maximum value you can take is E equal to V, and this is E equal to V line, and this is E equal to minus V line. So that means the variable U should lies between in this region, in this region. And let's find the Jacobian now. Jacobian is del U del X del U del Y del U del V del X del V del Y. So that will be del U del X is 1, del U, this half, sorry, this half, this is half, okay, things okay, I think it is right. So these will be half and this will be minus half. So this is basically nothing but 1/4. This is half. Okay, yeah, so this is half. Now we have to write the distribution of UV. That is nothing but UV small v is f of xy small uv and modulus of g. So yeah, I think I did some thing wrong here. So Jacobian will be, yeah, del x del u del x del v del y del u del y del v. So that is x equal to u plus v, y equal to this. So that means this upper will be 1 1, and del y del u will be 1, and this is will be minus 1. I think I did some del y del u. So that whatever that is, this is actually minus 1, this is plus 1 it will be. So this will become 2. So that means this distribution will be look like so if I put uv in place of an x plus y by 2 is nothing but u, right? Okay, I think I did something. Oh, okay, no problem. No problem, I did something wrong here. X means, so let me write it in this way, that this is v this is u. Then I think everything is correct. X is u plus v, y is u v minus u. This will be v minus u. Yeah, that's why I'm not getting it right. Yeah, then this will be simply half e to the power minus v. Now let's find the marginal distribution of u. Okay, does anyone have a comment? No comment yet. Okay, so distribution of f u will be if u is in the region, in this negative region, where in the negative region we have to integrate out v. So v start from minus u to infinity, so minus u to infinity f uv dv. This is for u in between minus infinity to less than 0. So that is, if I integrate it, half minus u to infinity to the power minus v dv. So this is half minus e to the power v minus u to infinity. So this is half e to the power u. And in the region of where u greater than 0 and less than infinity, there if u will be, so in this region v start from u to infinity, we start from u to infinity if uv small uv dv. So this is again let me do it, half u to infinity to the power minus v dv. So half minus u to infinity. So this is basically half e to the power minus u. So that means u follows a distribution f u, that is half e to the power minus modulus of u for u varies to minus infinity to plus infinity. Now that means it follows a Laplace distribution. That means u, which is x minus y by 2, follows Laplace distribution. So option A is correct. This is 0, I think. And since the distribution is symmetric about x equal to 0, that means its mean is actually 0. So that means expectation value of y, expectation value of x minus y is 0. So that means B is correct. C is obviously not correct, because C is since it follows a Laplace distribution, so it's not a normal distributed. So this is wrong. And half x minus y is symmetric, this is also correct. So that means the option C is not correct. So that is the solution of the question number 5. Let's move toward the question number 6. So question 6. Okay. Let's write the question 6. Test results is well TS from an electric board indicate that 60% of board 60% of board failures are caused by assembly defects. 30% are due to electrical components and 10% are due to mechanical defects. Suppose twelve boards fell independently let the random variable x, y and z denote the number of assemblies electrical and mechanical defects among 10 boards. Calculate the probability that x equal to 7, y equal to 3 and z equal to 2. So as the question suggests, is a trinomial distribution. So this question, the answer of it, so basically this x, y, z, this variable follows trinomial distribution with parameters n equal to 12, p1 equal to 0.6, p2 equal to 0.3, p3 is 0.1. That's it. And therefore the required probability is probability of x equal to 7, y equal to 3, z equal to 2 is 12 factorial by 7 factorial into 3 factorial into 2 factorial, 0.6 to the power 7, 0.3 to the power 3 and 0.1 to the power. So if you calculate, you get 0.05986. That's it. Okay, now let's move toward the question number 7. So this is question number 7. So it says the Cartesian coordinate x, y and z follows a random point moving in space are mutually independent, are this is the three are identically independent, identically distributed with normal distribution 0 to 1. Now the square distance of the point from the origin, so we have to, the square origin is we have to find the distribution of the uh, is equal to x square plus y square plus z square. You have to find out this. So this is very simple question. So since we know that these any identically independent distributed random variable which follows a normal distribution, the square of the variable follows this x square will follow a chi square with 1, y square also follow the chi square with 1, and z square similarly follow chi square with 1. And we know that if we add 3 chi square with order 1, the random variable will become the another chi square with order of degrees of freedom 3. So the answer will be this will be a chi square distribution with order 3. So that is the answer 7. Now let's move toward the question number 8. So here the question is consider the following statement, and we have to, so there are statements, so let's give the statements are following. I, if x1 to x1 x2 xk p in, so this is p independent binomial variates with parameters n1 p n2 p nkp, then summation I equal to 1 to k xi is a binomial variate. So this is true, so we're gonna see that this is true. Actually this is very simple. So the MGF of any random variable will be, since it follows binomial distribution, so e to the power t by 1 minus q e to the power t to the power ni. Q basically means 1 minus n. Now since all are independent, so the summation xi t1 dot t2, okay sorry, summation t, this is random variables, it will be nothing but the product of I equal to 1 to k m xit. So this, if we do the summation, we'll get p to the power t 1 minus q e to the power t, and this will be nothing but sigma I ni. So this is a another binomial variate with parameter sigma I ni and p. So that's it. So first statement is true. Now let's see the what is second statement. Second statement is second statement is following, that if x1 xk geometric distribution with some parameter p, then the summation of xi I equal to 1 to k follows gamma distribution, not geometric distribution. So second statement is not true. Now let's move towards the third statement. Okay, x1 xk follows a Poisson distribution with parameters mu1 dot 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 mu k. Now then, what is the Poisson? So again, let's see from the MGF of Poisson. MGF of Poisson distribution, we know that will xit will be e to the power mu into e to the power t minus 1, so that mu I. Now the moment generating function of this summation will be, since all these are independent, so these we can multiply them, so xit, so this is basically nothing but I equal to 1 to k e to the power mu I et minus 1, so this is e to the power sigma I mu I et minus 1. So basically this is again a Poisson distribution with its parameter sigma mu I. So that means the third statement, it is true. Third statement is true. Third statement is if all k independent variables are Poisson distribution, then the summation of those variables will be again a Poisson variate. So that is true. Now let's move towards the fourth statement. If x1 to xk, k independent variates with parameters n1 p1 n1 p1 n2 p2 dot 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 nk pk, where pi not equal to pj, then summation of xi is a binomial variable. So that is not correct, because to be a to summation to be a binomial variate, again the these probabilities should be same for all pi pj's are same. So the fourth statement is not correct. So that means only first and third statement is correct. That is its answer. Now let's move to the question number 9. Question number 9. So question number 9 is, let me do it. Question number 9. So if x and y are independent standard normal distribution. Normal distributed and r and theta is the representation in polar coordinate of point xy in Cartesian plane. Then distribution of r and theta r. So we have to find the distribution of r square and theta. So let's find it out. So x and y are independently standard normal distribution. So that means x and y both follows a standard normal distribution, and x equal to r cos theta and y is equal to r sin theta. Okay, let's x equal to r cos theta, y equal to r sin theta. So the Jacobian will be tail x tail r tail y tail r tail x tail y. I think tail x tail x tail theta tail y tail r tail y tail theta. So this will be r minus r sin theta. This is r cos theta. This is del y del r cos theta. This is this will be okay. I think I did something wrong here. Yeah, so that is with respect to r. Okay, that is with respect to r, so that is cos theta basically. R, this is with respect to sin theta, so this will be cos theta and r cos theta. I think tail y tail r is cos theta again. I think it's did something wrong. Tail x think tail y tail r tail x tail theta tail y tail theta. Now del x tail r means cos theta, this means sin theta, and these means, okay, let me once check, then I will think I did something wrong here. No, I didn't do it the correct way. Okay, let me do it again. So this is tail x, tail r, tail x, tail theta, tail y, tail r, tail y, tail theta. So this is tail x, tail r is cos theta, and del x tail theta is minus r sin theta. Now I get it correct. And del y del r is sin theta, and del y del theta is r cos theta. So this is r cos square theta plus r sin square theta. So this is nothing but r. Jacobian is r. Then f of x, y, x comma y since independent, so that will be f of x into f of y, y. So normally, since it is normally distributed, that means 1 by 2 pi e to the power minus x square plus y square by 2. Now then, f of r theta will be small r theta in f of x, y, r theta Jacobian, that is r by 2 pi e to the power minus r square by 2. And here r greater than 0 and theta belongs to 0 to 2 pi. Okay, now then the marginal distribution that of r will be integration r will be 0 to 2 pi r by 2 pi e to the power minus r square by 2 d theta, that is 1 by d, that is simply r e to the power minus r square by 2. And marginal distribution of the theta will be 0 to infinity 1 by 2 r by 2 pi e to the power minus r square by 2 dr. So that is 1 by 2 pi 0 to infinity r, okay, r e to the power minus r square by 2 dr. Let's okay, so if I consider these r square by 2 equal to z, so that will be dz is r dr. So this becomes 1 by 2 pi 0 to infinity e to the power minus z dz. So that is basically 1 by 2 pi. That means if theta is 1 by 2 pi, that means uniform distribution between 0 to pi, 0 to 2 pi, sorry. So that means the distribution of r square is these. So let this is a uniform distribution, and distribution of r square, let use the transformation if r equal to if r equal to r e to the power minus r square by 2. Now let's we have to find the distribution of r square. So since we know the distribution, so let's figure it out. What is the distribution of r square? We know that that is nothing but r square r, r square, suppose small r square equal to z, then f of r, so f of r square z will be, this will be f of r at z, this multiplied by dz dr. Okay, so this is 2r dz dr means, okay, let me write it here like this, dz dr means 2r, sorry, this will be again, this is be dr dz, this is dr dz, so this is basically that means dr dz is nothing but 1 by 2r, so this is r e to the power minus z by 2, this is 1 by 2r, so basically it is, and here z should be greater than 0, half e to the power minus z by 2. So this is basically a exponential distribution with scale parameter 2, and theta is a uniform distribution between 0 to 2 pi. Now this is the answer. Now let's move toward the next question, that is question number 10. That is question number 10. Okay. Question number 10 is following. Excuse me. Now, let x1 to x1, x2, x3, x5 and x6 IID. This is uniformly distributed random variable. This is 1 if in between 0 to 1 and elsewhere 0. Now suppose the PDF of x2 order statistics of 2 is g3 y2 a y2b 1 minus y2 c. Now y2 is a bit number between 0 to 1. We have to find the a b c. That means we have to find the distribution of y2. Now suppose now let's see how we can find it. Suppose that xr equal to yr, say. That means x equal to y, say. Now we have to find that what is the probability that x are equal to y. So we have to find the probability. Density means what is the probability that this is x are equal to yr. So this means that the r minus 1 previous one, r minus 1, suppose this means x1 should be less than yr, x2 should be less than yr. Similarly x3 xr minus 1 should also less than yr, and xr equal to yr, and all other variable from xr plus 1 to xr plus 1 actually greater than wire. So all up to, suppose there are n variables, so n should be wire. Now among the n variables, how many ways I can, so so since all these are independent, so what is that means the probability should be multiplied. So x1 wire, this is multiply I equal to 1 to r minus 1 and multiply I equal to r plus 1 to n p of x of I greater than wire. Now how many ways I can choose such numbers? So that is n factorial ways I can assemble it, and this is a one particular combination, and out of them if I assemble them they will not change it. So out of them r minus 1 factorial, and this is I think this is another n minus r factorial r. If I assemble rest of the them, so they will not affect it, so they will not affect it, they will not affect that x are equal to y. Now, and what is the probability of this? This is nothing but, since it follows a uniform distribution, so this is nothing but x to the power yr to the power r minus 1, and this is again 1 minus yr to the power n minus r. So basically this is a beta function yr r minus 1 minus yr n minus r, and this is actually beta r comma n minus r plus 1. Now this is any probability of this. Now it has been given that n equal to 6 and r equal to 2. That means then what will be the probability of x of 2 equal to y? That will be y to the power 1 minus y to the power n minus r, that is 4, and this is beta 2 n minus r, 4 plus 1 5. So this is that. So that means what is the value of a is beta, a is 1 by beta 2 5, so that is basically 30, and value of b is 1, and value of c, that means what is the power of 1 minus y2 to the power c, that is basically 4. Value of c is 4. So that means a comma b comma c is 30 1 4. So that's it. So that is the today's assignment solution section. So that's it. So now I'm gonna leave this meeting.